don't see a lanyard dangling there. If you could put that on, I'd appreciate it. Thank you. Today we'll start with questions from homeworks. Does anybody have anything? We've done worksheets 4, 5, and 1 updated. Yeah, Josh.
Worksheet 5, you do number 7.
Worksheet 5 ends at number 4.
Worksheet 4, I mean.
Okay.
Worksheet 4, number 6.
Yup. All right, so this reads, find the equation for the sinusoid that has a midpoint at 215 and the next extrema at 8, -5. So I'm going to just kind of start by sketching a picture of what I have. So I have 215, and we're told that's a midpoint. So I know, like, my midline goes through that. Oh my goodness, all these people. Nicole, Gavin, and Edie. Passes for you guys. Come and grab them. It says the next extreme is at 8, -5. So I know that's a minimum, right? Because -5 is smaller than 15. So I know it's below it somewhere. So if I draw my picture of like one full cycle, it would look like that, right? Does that feel okay? What I've just kind of drawn in? Done nothing sneaky so far. I just want to like have something to look at to help me figure out how I'm going to find these other parts. So I guess the next thing I'll do is I'll decide whether I want to do a sine graph or a cosine graph. Here I'm given a midpoint and a minimum, right? So I could write a sine function or a cosine function. I have good information to do both. Does that feel okay? Now, personally, I'm going to take the sine option because of the midpoint. And the reason I would pick sine over cosine is I know that that midpoint is the h comma k. So immediately, I have what I need. Is everybody okay with that? Which is nice. Like, sign me up for that. That's 2 down already. All I need to do now is find my A and my C. So remember, the A is like the distance from the midline to an extrema. So like that distance there, right? So if we started at -15 and we go down to -5, how many have we gone?
10.
Nope. So I'd start at positive 15, 20. I go 15 down, and then I do 5 more down, right? You buy that? Now, how do I remember whether I want a positive or negative if I'm looking at sine? So I'm going to use the picture to figure it out, right? Whether I want the plus or the minus. So depending on the midpoint that I've chosen to use, I chose to use this midpoint because it was given to me. I look at the next extrema after it. Since that was a minimum, tells me the A I want is a negative. Does that feel okay? Josh, you happy?
Yeah.
Okay. The last thing we need now is the period. So I remember is the C, and C is related to the period. So I'm going to look at my picture and say, okay, well, I don't have a full period here. But between these 2 points, how much of a period does that look like? A quarter. You see, you buy that? Because there's like, I have like another quarter here, and then like another quarter to there, and then like another quarter to there. Hi, Miss Moody. Sure. So what I want to find out now is how far is that 1/4 of a period? Remember, the period is a horizontal distance. So it's like the distance from 2 to 8. How far is that, 2 to 8? 6, right? So if a quarter period is 6, a full period is 24, because I multiply both sides by 4, right? And then the formula that relates period to C is 2 pi times the absolute value C. So to solve for C, I just divide both sides by 2 pi. So I can reduce that. I notice there's the 24 is divisible by 2, as is the 2 pi. So that becomes 12 over pi. And remember, we always use the positive version of C. So that's everything now that I need to write my equation. So y equals a, and we chose to use sine, and then the reciprocal of c, x minus h plus k. Does that feel okay, Josh? Yeah? We're okay? Bros.
It would have been different if you used cosine.
So what would have been different if I used cosine? So if I did this as a cosine equation, the only thing different would be that this would be the h, and I'd have to check my sign for a, but since I'm using a minimum, the a is still going to be negative. So if I wrote this as a cosine equation, the a was still negative because that point was a minimum. The period will stay the same. The h is different because it's based on the point, and the k will always stay the same. So the only things that can change are the sign on a and the h. When you write a sine function versus a cosine function, those are the only things that can change. The c and the k will be the same, no matter what one you pick. How did that feel? It's okay? All right. Let's do one of these graphing problems, because I don't think anybody's asked about one of these guys yet. So I'm just going to grab one.
I do Sunday.
Yeah, that's part of Sundays, but it could be on the homework quiz, right? So let's just kind of go through here and do one of these. So let's do, say, 13 here. Sound okay? So the first thing I want to do is I need to identify the values for A, C, H, and K. From the formula. So notice there was nothing added or subtracted to the end. So I'm going to write a plus 0 there to just kind of remind to me that k is 0. And hopefully everybody's super cool with like, hey, Mr. Kulik, that one's pretty obvious, right? The other one that's pretty obvious is the A. So those should be the first two we find every time because they're nothing sneaky going on there. Place we have to be careful about is the C and the H. Those are ones that are easy to mess up. So first things first, when I look at my general form, the coefficient on x is a reciprocal of c, right? So if the coefficient on x is 2, the value for c is its reciprocal 1 over 2, right? So that c is always the reciprocal for that coefficient on x. Mr. Kulik, what if there's not a number in front of the x? Then just 1, man. No big deal. Everybody's okay? The h, though, is a little bit tricky here because notice that in the general form, we're in a factored form, but we're not factored here. So before I can find the h, I have to factor that stuff on the inside. So that coefficient on x has to get factored out front. And then what is pi over 2 going to be when I divide it by 2, right? When we're factoring something off, we're dividing. It's not pi. It's pi over 4. Remember that dividing by 2 is like multiplying by 1/2. So 1 times pi is pi, 2 times 2 is 4. So we should get a pi over 4 there. So what is our h then? Pi over 4. Remember, the h is always the opposite sign of what it appears in the problem. Okay. So, if I know the a is -3, what's the amplitude? Everybody's cool with that? If k is 0, the midline is? Not 0. Gotta say it differently. Y equals 0. Remember, the midline is a line. It's not a number. Even tried to help you out on the worksheet because I put a colon there, not an equal sign, to say, like, don't just put a number here like the other ones. Like, write the equation. That's me trying to give you a hint that it's not a number, it's an equation, so it needs y equals to start. Mr. Kulik, will you really be that picky about it? Yes! But I'm telling you now that I'm going to be picky about it, so there's no excuses. All right, the period, how do we find that? The formula for period is 2 pi times the absolute value c. What's c in this case? A half. What's 2 pi times a half? Pi. And then what's the frequency? It's the reciprocal of the period. So, it's 1 over the period. 1 over pi. So far, so good? Okay. Now that I've done that part, I'm ready to write my function map. So that function map is always going to be cx plus h, ay plus k. So just fill in the values. Notice I didn't bother to write plus 0 for the plus k. I just left it minus 3y. You can write plus 0. It's not wrong to do that. But, like, it's not necessary. I'm going to save my virtual pencil lead writing that. Then I would go to my reference points list and copy those reference points in for sine, right? Because the problem, this is a sine problem. Now, do you have to have these reference points memorized? No way, Jose. In fact, on like a quiz or a test or whatever for a sine problem like this, on your paper, I'd have like this written out, just where there's a blank, you know, like where the AH or the CH, A, and K would go in the function formula, and then a blank for the new point that you're generating. So like I will give you the reference points for the problem. In fact, I'll put the right reference points in the right problem, so you don't even have to pick like the sine ones and the cosine ones. So there's no copying to worry about. I'll take care of that for you. I'm just going to put a blank. What's the new version of this point? What's the new version of that point, etc. You'll be in charge of doing that part. But like I would give you a setup that looks kind of like this to start. Okie dokies. All right. So if I plug 0 in for x, I end up with just pi over 4, right? 1/2 times 0 is 0. 0 plus pi over 4 is just pi over 4. 0 times negative 3 is still 0. So that's my first point. Pi over 2 times 1/2 is pi over 4. Plus another pi over 4 is 2 pi over 4, or 1/2 pi. And then negative 3 times 1 is negative 3. Notice how much did my x go up by? From pi over 4 to pi over 1/2. I'm sorry, pi over 4 to pi over 2. Pi over 1/2. What are you talking about? Went up by 1/4, right? So what do you think the next x is going to be? 3/4, right? Right, I had 1/4, I had 2/4, I had 3/4, I'm going to have 4/4, and then I'm going to have 5/4. Once I've established that pattern, I don't have to keep adding fractions the whole time. I can just go, oh, what's the pattern going on? And just extrapolate it out. What's the risk in doing that? If you made a mistake on one of those first 2 points, carries it all the way through. So you may want to double check one of those. I'm not going to do that because I have really high confidence in myself and my ability to add and subtract fractions in my head. But if you are not that person, you know, like, know yourself. Okay, I do the y's now. So 0 times negative 3 is negative 3. Negative 1 times negative 3 is positive 3. And then 0 times negative 3 is 0. So now I'm going to go ahead and plot these points. So this tick mark here is halfway in between 0 and pi. So that's pi over 2. So pi over 4 should be halfway in between that and 0, and like 3 pi over 4. So I'm going to need like halfway in between. I'm just going to kind of like draw on a little tick mark for myself. Is everybody okay with me doing that? So I start at pi over 4, 0, and then I have pi over 2 comma negative 3, and then 3 pi over 4, 0, and then I have pi 3, and then 5 pi over 4, 0. So there's my one cycle. But I'm going to fill the space available to me now. So I'm just going to kind of continue my pattern. Is everybody okay with me just kind of continuing the pattern. And now I'm going to just kind of connect my points. So the super critical piece that we absolutely needed to have to kind of move forward on this problem is remembering that function map, right? So the way the easiest way to remember it is that, like, well, the C and the H are affecting the X variable, right? And the C is being multiplied and the H is being added or subtracted or whatever, right? So like that's how I remember it, CX plus H. And then the A is being multiplied to the outside and the K is being added to the outside. The outside is really the Y. And there you go. Easy way to remember it is it's just based on that same kind of general form formula. Does that look familiar? Do you feel okay doing that? Again, if you can get the A, C, H, and K and manage to multiply some fractions effectively, it's usually not a big deal, right? The graphing is pretty straightforward, and using the method that I've described here makes it, very plug and chuggy, which you should be super happy with. Like, hey, I don't even really have to think that hard about this. I just have to make sure I don't make any silly mistakes. Like, once I understand what to do, it's not too hard, which is super nice. All right. We're going to finish up chapter 3 today by talking about graphing tangent functions. This is the last part of chapter 3 that we're going to deal with. This is what I want. All right, so let's say we want to graph we want to graph something like this. Y equals -2 tan of x over 2 plus 1. So again, just like graphing a sine or cosine function, going to be still the same kind of starting. So I'm going to start by identifying my values for A, C, H, and K. What is the A here got to be? Who can tell me? -2. Excellent. How about the C? Who whispered it? Kiara, was that you whispering? What? 2 is right. Be proud, right? So you're like, how is she getting that? Well, what if I thought about x over 2 as just 1/2 x? If I write it that way, is it pretty clear why C is 2? So again, got to think about, like, if you're not sure, like, what does it really look, how else could I write this thing to make it obvious for me? And that should make it super obvious. Okay, what's the H? 0. Why'd you get that, Edie?
There's nothing after it.
There's nothing else in the parenthesis being added or subtracted. Perfect. And then the K is 1. That should be easy. That's the one added to the end, right? So far, so good? Okay. Can I figure out an amplitude for a tangent graph? No! Tangents don't have any amplitudes, right? So we don't have to worry about that. Let's find its period, though, or its mid. Let's do the midline first, I guess. What's the midline? It's the same as how we do for sine or cosine. Y equals 1. Very good remembering to say y equals this time. How about the period? How do we do that? Sure. I thought maybe I was going to get a period answer, but... Now remember, the period was different for tangent than sine and cosine. Instead of 2 pi, absolute value c, tangent is 1 pi, absolute value c. So if the period's 2 pi, what's the frequency? 1 over 2 pi, right? Yes. Yes! That's what we're talking about. Okay. Now that we have this, we can write our equation. So again, I did cx plus h, ay plus k. Since my h was 0, notice I didn't bother to write plus 0. You could if you wanted to, but I'm going to save my virtual pencil lead, for later. As if those electrons are just going to be, hanging around till then. Okay, now I'm going to go retrieve my reference points for my function. I got to scroll down here. There's my tangent. Ugh, Mr. Kulik, what the heck does und mean? You guys hear that really irritating squeaking sound? You know what that is? It's the stupid fan on this projector that's like needs to be oiled or something. Isn't that like driving you nuts? I'm about 2 seconds away from climbing up there and just like taking a sledgehammer to the thing. But I'm going to try not to because I feel like I might get fired if I didn't. And I kind of need my job. Okay. Again, I'm going to ask this question because I started it and then got sidetracked by the annoying, whining sound from the fan. I have und in this point. What the heck does und mean? What do you think that's short for? Undefined is correct. What is that going to mean when we draw our graph? It's not a point. What goes there instead? That's where we're going to put the vertical asymptotes. Remember for the graph of tangent, we had those vertical asymptotes we talked about last time? Okay, so let's go ahead and finish this out. So what's 2 times negative pi over 2? Two times negative pi over 2. Negative pi. And guess what? Doesn't matter what you do to undefined, it still stays undefined. So I don't even care about the y. Just write undefined again. Is everybody cool on that? An asymptote's going to stay an asymptote. The location of it, where we draw that vertical line, can change, but it still is going to be an asymptote. It's still going to be a vertical line. And then we continue going on, right? So 2 times pi over 4. Oops, that should be negative pi over 4. Woo! That's going to be negative pi over 2. And then negative 1 times negative 2 plus 1 is 3. And I'm just going to kind of continue grinding away here. Is that okay with you guys? No? Yes? Maybe? If you say so, Mr. Kulik. Just like doing arithmetic here. I'm going to skate through it a little bit quickly. If you guys have big problems with how I did the arithmetic, please stop me and ask. I'd be happy to elaborate and go into more detail. But at this level, I'm kind of hoping that you trust me that, okay, I know how to do that. It may take me longer than you to do it, but if I so desired, I could go back and fill in those blanks if I had to. All right. Let's now draw a graph for this. And let's do that maybe from negative 2 pi to positive 2 pi. So let's look at our x-coordinates. What do you think our scale should be on the x-axis? What should each tick mark represent? What do you guys think? What's the change between the x-coordinates? Pi over 2, right? You guys see that? That's what I would pick as my scale, is each tick mark is pi over 2. So, oops. So like half a pi, 1 pi, 1.5, 2. Half a pi, 1 pi, 1.5, 2. Everybody feel good there? And then if I wanted to draw my y-axis, I go from negative 1 to positive 3. So I think just going by ones there seems appropriate. Sound good? Okay. So when I draw my graph, I'm going to start by just drawing the asymptotes first. So I have negative pi is an asymptote. Again, the asymptotes are the undefined parts. And then positive pi so I always draw that. I like to draw my asymptotes first. Is that okay with everybody? And then I have negative pi over 2, 3, 0, 1, and then pi over 2, negative 1. And I'm going to now connect my graph. So the asymptotes are going to kind of be my guide there. Make sure your graph has some curve to it. Mr. Kulik, are you going to be picky about if my graph has curve? Oh, you betcha. So it can't look just like a straight line. You know, if you try to do something like this, I'm going to mark that down because it looks like the graph is going to be crossing the asymptote if you follow your arrows the way you've drawn them. You guys see what I'm saying there? I'm going to continue my pattern. So I noticed that I needed like 5 tick marks, 1, 2, 3, 4, 5 to draw my next graph, right? I really only have 3 of them. So if I want, I can extend out like 2 more tick marks. Actually, let's do those in red. So that it makes sense there. So I'll put in my asymptotes. So notice that the asymptote that ends one cycle is the same asymptote that starts the next cycle, right? And then I can just kind of follow my pattern. What do you guys think? Not so bad, right? This is pretty doable. Now, Mr. Kulik, what if I had just done like that and not actually extended my graph out any further, and I had just done something like that? Would that have been okay? Sure, no problem. You filled the space. I usually think it's easier to draw a full cycle to fill the space. But if you can fill the space without having to draw the rest of the cycle, that's okay too. No big deal. You guys get what I mean there? So again, probably not the way I would do it, but it's not wrong, right? Just need to fill the space provided. What I want to talk about for a second now is Yes, sorry, Jetson. Certainly. Say hi to Brody. All right. The other kind of question I want to ask you guys is, where are the vertical asymptotes for a graph like tan of 2x plus pi over 8? So to do this, what I need are just the c and the h out of my function. So if I look at this, what should the c be? 1/2 sounds great, right? 2, if 2, the coefficient on x is my 1/c, its reciprocal should be just c. Then we need to find h. But what do we need to do to h before we can find it? I'm going to have to factor, right? So if I factor that 2 out, what does pi over 8 become? Actually, let's change that pi over 8. That's an annoying number. Let's make that pi over 4. Sorry about that. So when I factor that 2 out, it's like dividing by 2. So pi over 4 divided by 2 is pi over 8. So my h is negative pi over 8. Very good. Remember, the h is always the opposite sign as what it looks like in the equation. Okay, so I'm going to go to my key points. And I remember from my key points that, or my reference points, negative pi over 2 is the location of my very first, or really any vertical asymptote in tangent. So I'm going to kind of be using that pi over 2. And what I'm going to do is I'm going to find out where the new location of that is going to be. So I'm going to do cx plus h. Actually, let's write it as minus rather than plus a negative. Remind us what we did there. So 1/2 times negative pi over 2 is negative pi over 4. And then if I subtract pi over 8 from negative pi over 4, that's going to be negative 5 pi over 8. I made a common denominator and stuff to do that. So this is the location for one vertical asymptote, right? Where is the next vertical asymptote going to occur? It's either going to be one period before or one period after that one. Everybody's okay with that idea? So it's going to be that x plus one period is going to be the location of my next vertical asymptote. So how do I find the period? Well, that's just pi times the absolute value of c. So that's pi over 2. 5 pi over 8 plus pi over 2, when I make my common denominator, is going to be negative pi over 8 So the fancy way of writing this is all of my vertical asymptotes I can write as x equals, it's the equation of a line, but since it's vertical, it's going to start x equals rather than y equals. And then it's going to be the location of one vertical asymptote. Any of them is fine. We found negative 5 pi over 8 plus 1 period pi over 2 times k, where k is just, well, let's use a different letter. What's a free letter that we haven't used yet? We did A, C, H, and K. Let's do B then. Does that sound okay? Where B is just any integer. So if I go 2 periods, that should be another asymptote. Or if I go 17 periods, that should be another asymptote. Or if I did minus 8 periods, that should be another asymptote. Everybody okay with that? So this is the way that we kind of write our final answer. So we just start by finding the first asymptote. Well, actually, it doesn't even have to be the first. Location of any asymptote, I always just use that first key point. And then plus the period, whatever that is, times that constant, which is just any integer. So this symbol right here is just saying the period times any integer. So the b is a free variable, and that symbol afterwards says b is an element of the integers. The little curvy e means element of, and that fancy looking z is the symbol for integers. Do you remember talking about that in Algebra 2? Some shakes yes, some blank stares. That's what it stands for. That's all I, yes, sir.
Where did you get the 5 from?
So I had negative pi over 4 minus pi over 8. Ooh, should that be a 3? That should be a 3, huh? Thanks. Well, I made a common denominator, apparently not correctly, though. Now it's correct, though. Oops. But that's what I did there, Troy. Does that feel better?
Yeah.
Okay. Yeah. Woo! Glad you caught me. I think I forgot the 1/2. I just did negative pi over 2. Yikes! See how easy it is to make a mistake? Okay, that's it for 3-2. So those are like the 2 types of questions you're going to see in the homeworks. The homework that I'd like for you guys to do for this is going to be numbers 15 through 24. So I think that's 9 problems. If I look at those problems, they're going to be, use that language of transformation. So like vertical stretch or reflection or shift left or right, up and down, that kind of stuff to describe what's going on. Find the vertical asymptotes. Identify the period and then graph on the interval. So just like the stuff we practiced here. Okie dokies. Okay. Clear your desks. It's homework quiz time. Pencil and calculator.